we're still on the first objective, objective A of this unit. However, now what we're trying to do, first of all, let's remember that objective A is writing equations of lines. So let's just go back a little bit and review that here, I was giving you an equation of line, and your job is just to solve it for y. These equations, 1 through 15, were all in standard form. When I get to 16, we can see now that something's changed. They're not in the same form at all. So in 16, instead of x then y, the number, I've got stuff kind of everywhere. The process is going to be the same. The process still, in order to write this and make it y equals mx plus b, our job is going to be to solve for y. What changes is the fact that no longer is it the exact same thing at any time. But I think if I look at this, I know y needs to be by itself, so I need to get rid of this 2 by subtracting it. Y's left over, and x plus 1 is here, and there's my equation of the line. Good to go. So I think that not much is going to change in this, and I think this will probably end up being a short video for you. But as we go through, we can see I am doing the arithmetic a little differently. Let's move on to the next page, and we can see, uh-oh, now I've got parentheses. So before I think about doing my line on 17, I want to look and say, wait a minute, I can do a distributive property here. So the y plus 5 has not changed, but now I'm going to be left with 5x plus 10. And now I can draw my line, if needed at this point. Subtract 5 from both sides. And now it's in slope-intercept form. Right? As I go down to 19, I'm going to skip 18 because it's very similar. 19 now we're dealing with a fraction. And we are going to have troubles with fractions. We're going to just have to get used to it. We saw it earlier on. We saw it in chapter 2. Fractions are here to stay. So I need to distribute that whole thing to both sides. Well, first of all, the y minus 2 is going to stay. But negative 5/3 times x is just negative 5 over 3 x. But this other part right here, that's an issue. And what we want to get used to is just simply using our calculator to its fullest potential. So I'm going to bring up the calculator, and we're going to see if this really isn't all that bad. All right. So if I need to do negative 5/3 times 3, I'm going to plug that in my calculator as is. I'm going to do it in parentheses. I'm going to do negative 5 divided by 3 times 3. And look at that, my answer is a whole number. Remember, if I need to make this answer a fraction because I got decimal, I just hit math, enter, enter. In this case, I don't need to worry about it. Use your calculator to do this distributive property with fractions, and then it's not a big deal. So anyway, back to my problem. Negative 5/3 times 3 was simply negative 5. And now I'm ready to do my line down the middle and add 2 to both sides. And now here it is in slope-intercept form. So there's some things we want to point out before we go too much farther. And let's hold off to one more example so you can see it. Then we'll start pointing stuff out. When I get down to 21, my distributive property is going to look like this. Don't forget to distribute that whole thing. So this minus sign goes to both terms there. I do see that a lot, especially in the lower levels. The left side did not change, so we're left with that. Line down the middle. And here's my equation. see that really the solve for y portion is not all that bad. Not much is going to change here. However, I want to point out some things. As I look through the three that I did here, first of all, we know that this is the slope in each line. Slope, slope, slope. As I compare, I notice that that slope is always equal to this number right here, which tells me that that number in the original problem must have been sloped, or else that's a big coincidence to have that happen, what, 3 times in a row there. So what we're actually dealing with here is another equation of a line. So we had standard form, we had slope-intercept form, and our last type of equation is something known as point slope form. And it's probably the most useful equation we're going to have. And what it says is that I'm going to have a point and a slope. Up above, I had a slope and a y-intercept. One of the hardest things people have, if I have a point and a slope, that looks like this. I'm given m equals some slope, and I'm given a point, x1, y1. And we put this into an equation like this, y minus y1 like so. Now, people get confused, why do I have multiple x's and y? Well, the big X, the x and the y without the number on it, simply correspond to these x's and y's. They represent every point on the line. These, with a little number, represent a very specific point that happens to be on that line. So there is a little difference there. Okay. All right. So as we can see now, all of these are in what's known as point slope form. Don't get worried when you see something like 28. This is simply a special equation. And to solve it for y, oops, let's go ahead and do that correctly. Subtract 4 from both sides. And we want to remember that, oh, okay, this was a special equation that was graphed 1, 2, 3, 4. Like so. Let's go ahead. I'm going to make this so it kind of shows up a little better for you. 1, 2, 3, 4. Make that a little easier to see. And there's your line. Y equals negative 4. Good. Now, as we can see, most of this from 1 through 30 is not any different. Let's do one last one so you can see it, and then we'll move on. I'm going to do 29. So I'm going to distribute. Make my line down the middle. And there's my equational line. Because now you know that this original was in point slope, and this is in standard, you can check your work by saying, do the slopes match? And yet, they should match because it's the same no matter what type of equation you're writing. All right, so on 1 through 30 now, from 16 to 30, go ahead and try those problems, and we should end up having 1 through 30 complete before we move on to 31, which is still going to be right the equational line, but you can see now in 31 things change significantly. So again, try them out, and we'll come back when you're ready.